In our second example problem in chapter 9, which comes around slide 49, okay, it's labeled as an example test problem, we are given 5 grams of neon at a pressure of 256 millimeters of mercury and 35 degrees Celsius and asked to find the volume. The first thing that I'm always paying attention to in chapter 9 is that I'm working with the right units. Okay, so my 35 degrees Celsius, I know I need to take to Kelvin, right? So 35 plus 273 means I'm now working at 308 Kelvin. My 256 millimeters of mercury, okay, that's a unit of pressure, but I want to be working in atmospheres. And I know that 1 atmosphere is equal to 760 millimeters of mercury. Okay, that was done in the first video from the chapter. So I take 256 divided by 760, and I get 0.337 atmospheres. Okay. So now I've got a good unit for temperature, I've got a good unit for pressure, okay. 5 grams of neon. I need to find the equation that relates those three quantities. Okay. And the only one that exists from the chapter is this one. molar mass, equals mRT over PV. Molar mass equals mass times R, the gas constant, times T, temperature, over pressure times volume. Okay, so you would have to pull the molar mass of neon from the periodic table. You'll always have that available to you on a quiz or a test or a homework. The molar mass of neon specifically is 20.18 grams per mole, is equal to the mass that we're dealing with, okay, 5.0 grams, times the gas constant, 0.08206, liters times atmospheres over mole times Kelvin. Okay. Our temperature in Kelvin, which was 308, over our pressure, 0.337 atmospheres, and lastly our volume, which we were asked in the problem to solve for, the volume that this occupies. So I am going to solve this problem, first multiply everything in the top and divide it by 0.337. Okay, so I take 5 times 0.08206 times 308. Okay, that comes out as 126.37. Divide that by 0.337. That's coming out to 374.99. So when I do that, 20.18 grams over mole, okay, I come over here, I've combined these four quantities here, right, and that gave me 375. And if I look at my units, okay, atmospheres have canceled one another out, Kelvin have canceled one another out, so I'm left with 375 grams times liters over mole over my V. Okay. So now I'm going to bring that V over here, okay. 20.18 grams per mole times V is equal to 375, okay, grams times liter over mole. Divide both sides by 20.18 grams per mole. Which means grams per mole cancels everywhere. I'm left with final volume. It's equal to 375 divided by 20.18. And I get a final volume of 18.58 liters. I am limited in this problem by my temperature and my grams, which were only given with 2 sig figs. So I round my final answer to 2 sig figs, which would be 19 liters.